Another great feature of the lens is a thing called the macro feature. It allows you to zoom in really closely on subjects, am I correct?
Yes.
Talk a little about macro and what that does.
Well, it's used artistically. There's a connector at the back here, and we can take that away to a remote macro control, focus control as we call it.
Right.
And people who like to do, might be in a commercial or something, or a home shopping type environment where they want to introduce, let's say, a piece of jewelry, and they would like to start with a totally defocus image. And then come in with a little beautiful focusing action to a precision focus and no breathing, etc. Well, there's an optical system at the back elements here that we control with that macro focus that allows that. And it also allows you to get, for certain other shoots, to get closer than the MOD, minimum object distance of the lens. And that can be used for some other close-up work.
Boy, such a big lens to shoot a little ring, huh?
Yes, indeed.
One thing I want to talk about now is, we live in tough economic times. Stations' budgets are being reduced or limited, so to speak. The lens is not cheap, but yet you see the major networks like the CBS News is using it, ESPN has it. How do they justify kind of the return on investment on a lens like this?
Well, you have to think about the world we live in today and the sheer breadth of program genres that we have out there. I mean, you have the very, very high-end television dramas, episodics, and you go down through all sorts of categories of shooting, all the way down to low-budget work, perhaps for cable systems, etc.
Sure.
Associated with each of these are production budgets. Now, when you're at the top, production budgets are very large.
Right.
And of course, everybody there wants the best. So they're going to invest in the very best HD cameras. They're going to spend serious money on very beautiful sets. And of course, they've got top-notch talent. So to get the maximum HD quality, you've got to put a really, really good lens on that terrific camera.
Okay.
So in that sense, producing top-notch, high production, value-added programming, you want the best camera, the best lens. It's that simple. And you can justify the cost of this lens and that camera within that budget.
Great, great. Do you think a lens like this also makes the camera better? Let's say I've got a limited budget, I need to upgrade my studio, I've got cameras and I've got lenses. Which do I do first?
Well, a lens and a camera is a complex imaging system. People sometimes underestimate that. The lens is designed to work with cameras and the prisms inside camera, very careful design criteria there. So you really, if you're seeking the best, you really always need to think of the two together. Ideally, you'd buy a new generation together to get the very best. However, that said, people do have cameras and they want to get some more life out of that camera. It might even be a standard definition camera. You put a lens like this on a standard definition camera, you're going to get an awful lot better standard definition picture. And now your picture sharpness will come from the lens. You can back off on the image enhancement systems in the cameras and get a far more beautiful picture, a picture especially flattering to talent. Facial reproduction in standard definition has always been a taxing challenge, lighting, skin tone detail, all the electronic tricks. The best trick is get the sharpness from the lens, back off on all that digital stuff. And that translates also to high definition. And indeed, some of the networks that we sold this lens to, there was extensive testing of the lens, the camera, lighting, makeup, to make sure that high definition did justice to all sorts of talent, male, female, different ethnic groups, etc. It's a big issue.
And is there a way that I can actually test the lens and perhaps in my studio? I mean, so I know what it's going to look like in my studio. How do I do that?
Yes, we do assist and we do recommend, frankly, that if you're going to make an investment like this, that you do check us against the competition.
Yep.
And there are many test charts out there now, highly refined test charts that allow you to examine all of the parameters I listed.
Yes.
So there's that technical testing that the chief engineer of an establishment can conduct, and we can certainly help, and I'm sure our competitors will bring in their people to help, and that's a proper dynamic.
Okay.
But after that, you really then have to bring in the production people.
That's a good point. So then perhaps you should look at the production that you do, right? As far as, do I do reality TV? Do I do, kind of talk shows? That makes a difference as far as the lens you choose also, doesn't it?
Oh yeah, I mean, consider a talk show in the studio where you might have a table and you might have Barack Obama on the extreme left, and you have John McCain on the extreme right, you've got Jim Lehrer in the middle. All three of want to look good.
Yeah.
And if Jim Lear is looking better than the two guys in the extremities, you know, there's going to be a question about that. And that's what a lens like this tries to do, is to make sure everybody, the textures of the clothing, the hair, the facial textures of that are beautifully reproduced. That's your studio lens's task, and that's what we try to achieve with this lens.
So at the end of the day, quality matters.
At the end of the day, in HD TV, on big screens in the living room, with Blu-ray as a yardstick, quality is going to matter more and more in the future.
You know, with such a complex kind of architecture of this lens, do you think that I'm going to use less light in my studio with this kind of a lens? Because again, there's that wide aperture that you can reduce if you wanted to.
Oh, very, very.
I mean, the high sensitivity, right?
Yes. Yeah. The maximum aperture of this lens is f1.5.
Wow.
And you can typically, the sweet range of this lens will be f2.8 to f4. When I say a sweet range, most of your imaging parameters are pretty optimized in that range. And with cameras today, contemporary 2/3 inch cameras today are f10, f11 in their electrical specifications. You can achieve with f2.8 here, you can be shooting with 50 lux, 100 lux maximum, and making superb pictures.
Okay.
So that allows you to have your lights a little lower, save some power, and don't cook the talent.
That's right. That's right. That's great. And do you see the networks obviously have embraced it. Do you see it coming down market, so to speak, the mid-level stations, production studios embracing this lens as well?
I think some will, but not all. There's definitely a trend in the mid-level stations to look at the lower cost cameras and lenses. And we have such a spectrum of lenses at different quality and pricing. But there will still be the few, those who do seek, you know, there are perfections out there who want the best HD. And a very important point for all to think about is the nature of HD, that in the living rooms, we've got screens getting bigger and bigger. I mean, 60 inches are out there now. They're 1920 by 1080. My goodness, some of them are 60 frame, 60p. And they're going to continue to get bigger and bigger. You've got Blu-ray coming into the living room.
Sure.
And Blu-ray, with its quite extraordinary quality on this big screens, is educating the consumers on picture quality. So anybody who's putting out a studio picture over the air, which is the signature of your station, needs to be cognizant of that. Your studio picture's got to look great in that living room, because it's going to be judged. And a lens is a tremendous help to that, no question.
It'll actually improve your on-air image, is what you're saying?
It will. A lens of this performance is going to deliver to the camera just tremendous imagery. There are many performance parameters in a lens, and they're all optimized in a lens this expensive and this quality.
Right. Speaking of that, I understand there are about 20 different glass elements in this one lens, which is amazing when you think about how hard it is to get it right, so to speak. And talk a little about how, you know, because of that, number one, it takes a lot of R&D to do that and manufacturing, but secondly, no two lenses are exactly alike.
Well, first of all, start out with a lens like this has almost 3 dozen elements in it. And yes, it is true, 3 dozen elements, there's about 20 different glass materials used. All of those elements are degrees of freedom for our design engineers. The more elements you've got, the more degrees of freedom you've got to optimize a number of performance parameters, not just a picture center, but across the whole image plane. And that's what these type of lenses try to do, is get the best quality across the entire image plane. Contrast ratio over it, light distribution, picture sharpness center to corner. Very, very important.
No two lenses are exactly the same because of such a difficult manufacturing process.
Well,
is that an issue with the studio when you have 3 lenses in the studio? Let's say?
It's not, because there is a fundamental issue of tolerances, because you've got an awful lot of elements in there, and glass is very physical. You have to cut it, you have to polish it, you've got to achieve surface tolerances within nanometers. And the whole name of the game is to be able to assemble a bunch of lenses so that the cumulative tolerances fall within certain specifications. And once they fall within these tight specifications, which are checked in QA before the lens is shipped, then you have a match between lenses that's more than satisfactory. And that's what we achieve.
Okay. Well, thank you, Larry. You've been watching Advances in HD Technology. I'm Mike Botticelli with Larry Thor. We'll see you next time.